Alright gang, so told you guys would post a video of some of the work done on the odd problems of the study guide. Remember, you're required to complete the evens and it will be graded as an alternative assessment. And we will be having a test tomorrow, so I definitely recommend watching this video, doing the required problems obviously, but you might want to try some of these extra problems as well. So we'll try to review some of the topics as well. To rewrite in logarithmic form. When we rewrite something in logarithmic form, we're going from exponential form, which this is in, to logarithmic form. So we're going to have a log in there as well. There's three blanks we're going to fill in. I'm just going to put them as question marks to start off right now. These are the three spots we're going to fill in. There's log with a base. This spot is our answer, we call. This is the exponent. So there's an expression that I know some teachers have said, logs are bae. I don't know if you quite feel the same way about that, but it's one way to remember it. We're going to translate this in. Now, we also could just do our arrows going counterclockwise. And these are in order, the way we're going to write our answers. So we're going to write log with a base of x. Notice with the arrow, the next number is 64 that connects to. 64 is the next one right here. And when it crosses the equal sign, we write the equal sign again. And we put it equal to our last number, 3. That's how we translate it into logarithmic form. You can use these counterclockwise arrows to fill in your 3 spots. The final question is, find the value of x. We're asking ourselves, well, what value of x raised to the third power equals 64? Or, we look over here, x to the third power equals 64. What's that value of x? Well, in this case, the value of x is 4. Because 4 to the third power is equal to 64. Looking at problem 3, we're going to go from log form into exponential form. Use this counterclockwise technique one more time. And we write this as 125 to the power of w equals 5. And over here, 5 to the power of w equals 1 over 125. Now, to solve for the variable, we're asking ourselves, you could think of it as 125 to what power equals 5? The solution to that problem is 1/3. The reason being is the third root of 125 is 5. We talked about this right before we went on this COVID-19 break, if you will, but 1/3 is the same as the third root when we use it as an exponent. So w is equal to 1/3. Over here, 5 to what power equals 125? That would be -3. 5 to the third power is 125. 5 to the negative third power writes that as the reciprocal, or 1 over 125. Now, looking over at our next odd problem, by all means, but feel free to pause this video or try to play, pause, go back and forth, see if you can kind of match your answers with mine. We want to expand a logarithm. When we expand a logarithm, we're going to be converting our singular log expression into multiple log expressions. So I want to have this log over and over again. So we have log of 3. Now, it's 3 times the next value. So we're going to put that as a plus. All right? And it's going to be 9 log of a. I'll come back to that one in a second. Plus log b. When something's being multiplied 3 times a to 9 times b, we convert that into plus log of that value. All right? The 9 comes from this exponent. Any exponent, we don't leave it as a to the 9th. We take this 9 and we put it in the front. An exponent becomes a coefficient in the expanding. Okay? Likewise, I'm not going to do this when I say this one for you guys, but likewise in division, those problems get expanded, but instead of a plus, we're going to write it as a subtraction problem. Now this is the reverse. This is where we condense. I have log, log, log. I want just one singular log expression. So my final answer is going to have log written once. Now it's going to be the log of what? Well, 4a, that 4 goes back in and becomes an exponent. And as a plus, that's times b. Notice we have a minus now. That means there was a division originally. Divided by c to the 9th. Remember, this 9 becomes an exponent with that c. Okay? Moving on. See, I'm trying to do like one of each topic so you guys can use it and match up. Now, you guys have a lot of good resources. You have your notes, you have your solved examples, you have your video examples that I've posted, as well as Ms. Furman has posted, as well as some of the things on Khan Academy to go back and study from. The equal powers property. Now, to solve the equal powers property, the idea of this is to try to get this to be the same base on each side. So 3, 2x minus 5. I can write 27 in terms of a 3. Specifically, 3 to the 3rd power is 27. Now we call this the equal powers property because if I have 3 raised to a power equals 3 raised to a power, well, the 3's are already the same. That means these exponents have to be equal. The equal powers, the powers are equal to each other. So we can write an equation like this. 2x minus 5 must equal 3. Conversely, I could also say like they just cancel each other out and the exponents drop down. But now we solve this like an algebraic equation. We add 5 to both sides, get 2x equals 8, divide by 2, and you get x equals 4. Checking out the equal logarithm property, very similar concept to equal powers. I had the log of something equals the log of something. Well, they're each taking the log of it. So therefore, these two portions, the value I'm taking the log of, must be equal to each other. X minus 8 must be equal to 3x minus 12. Another way of looking at it is say, well, I got the log on both sides of the equation. They almost just cancel each other out. Now, again, in real math talk, we don't necessarily say logs cancel each other out, but for our purposes in class, we kind of think of it that way. To solve this problem, now I would have to get all my variables to one side and all my whole numbers to another side. So you can get either way. I can bring x to this side or 3x to the other side. Doesn't really matter. But let's say I bring like x to this side. I'm going to have 2x equals 4. And we're going to end up with x equals 2. Right? And again, I'm skipping some of the algebraic steps because that's something that I expect you guys to be able to solve. Bring your x or whole numbers to one side or the other using inverse operations and solve accordingly. Now, this next one is going to involve a little bit of rounding because we're not going to get an exact answer. Okay, so we want to take the logarithm of each side. We're going to take the log of each side of the problem. Now, why are we taking the log of each side? Let me explain that real quick after I write it down. We take the logarithm of each side of the equation for a very specific reason. I can't use that equal powers property because I can't get 4 or 3 to be an expression of the other. Like 3 to a power is never going to be equivalent to 4. And 4 to some power or 2 to some power, whatever we want to try to break it down as, it's never going to be equivalent to 3. They're going to be able to get these bases to be the same. So I can take the log of each side. By taking the log of each side, essentially I can rewrite the left-hand side as x minus 2 log 3 equals log 4. Remember we talked about in the expanding section. An exponent can just be dropped to the front. So this exponent is just going to the front as a coefficient. Now, this is just a number. Log 3 and log 4 is just a number. What we're going to do is we're going to divide both sides by log of 3. And this is going to be some decimal answer. I'm not going to type in my calculator yet, but you will be doing that momentarily. Now, what I'm showing you right now is the exact answer. We're going to add 2 to both sides and have x equals log of 4 over log of 3 plus 2. That's my exact answer. To find my approximate answer, like what I have in the instructions to round to nearest 10, this is where I would just take this, put that into a calculator. Log of 4, enter, divided by log of 3, get us some decimal equivalent, and then add 2. I'll leave the calculator section for you guys to work on as an exercise. For 15, if we want to exponentiate each side, all right, what I'm going to do is first I'm going to combine this into a single logarithm expression. We're going to combine this to be log base 4 of x minus 13 equals 3. Notice how by combining this plus, we kind of translate to be a multiplication problem now. It's going to be x times x minus 13, which can also be written as log base 4 x squared minus 13x. That just comes from distributing the x into that parentheses. Now, the exponentiated equation, that means to write each side, basically it becomes the exponent of an equation. So watch what happens. I'm going to put a 4 down here on each side. And there's a reason why. The reason why is 4 to the power of log 4 cancels each other out. So we can rewrite this equation. I'm going to rewrite over here. The left-hand side, I just have